Hello, my name is Mr. Fallen. In this video, we're going to look at problems 15 through 21 in section 10.1 of Module 5. It's the first section of Module 5. So on the screen, the problem number 15, the first problem we're going to look at, we have 4.5x minus 5 equals 3.5x. So to solve these equations in section 10.1, it's going to require using the addition property of equality to isolate x to one side of the equation. And that's all we should have to use is the addition property. So we shouldn't have to do any multiplying or dividing. Um, in order to make that happen, sometimes you have to be a little bit careful how you go about it. So here what we're going to do is get x just on the left-hand side of the equation. We have x on two sides of the equation, right? We have x over here on the left-hand side. We also have x over here on the right-hand side. I want it to just be on the left-hand side only, which means I want to get rid of this term that has x on the right-hand side. Since it's a positive 3.5x, I can cancel it out or get rid of it by subtracting a 3.5x. That'll make it go away, so it no longer exists on the right-hand side. But the rule is if I do something to the right-hand side of the equation, I got to do the same thing to the left-hand side of the equation. So I'm going to subtract 3.5x from the left-hand side as well, and I'll just combine it with like terms. So I'll combine it with the 4.5x. 4.5 minus 3.5 is going to be 1. So we'll get 1x, which the 1 really doesn't need to be written, but I'll just put it there for now. The minus 5 didn't do anything, so we're just going to copy it down. Same thing with the equal sign. And because we eliminated everything on the right-hand side and there's nothing left there, we need to use a 0 as a placeholder. So we don't want to just completely ignore the right-hand side or pretend like it's not there. We still have a right-hand side to this equation, and so we need to put something there, so 0 is the appropriate thing to put. So now that I have just one x in my equation, I can get this x by itself by getting rid of the minus 5. And so I'll do that by reversing that operation and adding 5. That cancels out the minus 5. If I do that to the left-hand side, do the same thing to the right-hand side. So I'm going to get 1x, which is just x. 1 times x is just x. Copy down the equal sign. 0 plus 5 is going to be 5. And again, the minus 5 and the plus 5 cancel each other out. And so we get the solution that x is equal to 5. So again, we get the equation to tell us what the solution is. All right, let's take a look at the next example, number 16, and see what we have. All right, so this one's getting a little more interesting. We have 8p plus 4 equals 10 plus 7p. So using the same reasoning that we did in the previous problem, I'm trying to solve for this variable p, which is on both sides of the equation. And I'm not going to be able to solve for it while it still exists on both sides. So I need to get rid of it from one side of the equation. So I'll elect to get rid of it from the right-hand side by reversing this operation. So the opposite of adding 7p would be to subtract 7p. And that's going to cancel it right out. But if I do this to the right-hand side of the equation, I got to do the same thing to the left-hand side of the equation, subtract 7p. And so I'll write it underneath the term that it's going to affect. So 8p minus 7p gives me 1p. I'll copy down the plus 4. I'll copy down the 10. And once we do that, we reduce the equation to a form that you should have seen earlier in this section. So earlier we were doing homework problems that looked very similar to this. So we're right back to that kind of problem. So it takes one step to get us there. We're still trying to isolate this variable. So I want to get rid of anything that's around it, which means I want to get rid of this plus 4, and I'll do that by subtracting 4 from both sides. 1p, 1 times p is just the same thing as p. Copy down the equals to. 10 minus 4 is going to be 6. And I keep skipping over this, but the plus 4 and the minus 4 are canceling each other out, which is why I'm ignoring it, because in my mind, it's gone already, so I don't even think about it. But that's what happens to those two numbers. Right, so we end up getting p equals 6. That's going to be our solution. All right. Let's take a look at the next problem, number 17. All right. We have 3 minus x equals negative 2x minus 11. Same rationale as the previous example. We are trying to get x by itself on one side of the equation. And so I'm not going to be able to accomplish that while x is on both sides of the equation. So my first task is to get it so x is just on one side of the equation only. And so I'll do the same thing I did in the last problem. I'm going to cancel out this negative 2x by adding a 2x. Right? It's negative, so to cancel it out, I need to add by a positive. And so negative 2x plus 2x cancel each other out. So x gets eliminated from the right-hand side. But if I do this to the right-hand side, I got to do the same thing to the left-hand side. So the 3 is not doing anything. We're just going to copy that down. Negative x, don't forget that negative sign, negative x plus 2x is going to come out as positive 1x. Right? Negative x, there's an invisible 1 here. So we have negative 1 plus 2, which is positive 1. And the x just gets copied down. Equal sign gets copied down. And don't forget about this minus 11, which now becomes a negative 11. So oftentimes I'll get students asking me, what's the difference between a minus sign and a negative sign? And I always tell them, really, there is no difference. A minus sign is a negative sign. We just give it a different name depending on the context. So if there's something in front of it, it's a minus sign. But if that goes away, it becomes a negative sign. But it really kind of functions in the same way. All right, so let's get down to business here. We're trying to get x by itself, which means the 3 needs to go. It's a positive 3, which is being added to the x. And so I can get rid of it by subtracting 3. Positive 3, negative 3 are going to cancel each other out. If I do this to the left-hand side, I do the same thing to the right-hand side. And so 1 times x, every time, I really don't need to write the 1. I'm just doing it so that you can see what happened to the numbers here. 1 times x simplifies to just x. And many people, most people, just write it that way to begin with instead of waiting. So a lot of people just put x here. We have negative 11 minus 3, so they're both negative. So that's going to come out as negative 14. All right, and that'll be our solution. X is equal to negative 14. Okay, these problems are going pretty well. Let's take a look at number 18. All right, so we have in the same vein, so these problems all kind of follow each other's lead here, and that they are structured in very similar ways. We're trying to solve for y. It's on both sides of the equation, so I want to fix that. So y is only on one side of the equation. I can do that by eliminating this negative 5y, and that's accomplished by adding a 5y. So those will cancel each other out. If I do this to the right-hand side, I do the same thing to the left-hand side. So we get negative 4y plus 5y. The negative 4 plus 5 is equal to 1. And the variable part just gets copied down. Anything else that was not addressed in this equation just gets copied down as well. So I don't know if addressed is the right word, but you know what I mean. Anything that was unaffected by what we just did gets copied down to the next line. That includes the plus 4, the equals 2, and the positive 7, which we can just write as 7. Since the 5y is not there anymore, the plus sign doesn't really need to be written. It's technically there, but it's invisible. It's a positive 7. We just don't bother to write the plus sign when it's positive. If it was negatives, if this was a minus 7, we would write the negative sign. It'd be negative 7. So to get y by itself, the plus 4 needs to go. We will get rid of it by subtracting 4. That'll cancel it right out. If we do that to the left-hand side, we do the same thing to the right-hand side. And so we end up with 1 times y, which is y, copied on the equal sign, 7 minus 4, which is going to be positive 3. And that would be our solution. All right, let's take a look at number 19. All right, so we have 14x. So these are starting to get a little repetitive, right? 14x plus 9 minus 4. Okay, this is a little different, but it's not going to be too much for us to handle. Equals 13x minus 4. The extra term being thrown in here on the left-hand side is very quickly dealt with by just combining like terms before you start moving things from one side of the equation to the other. So before I start subtracting from both sides of the equation or adding to both sides of the equation, you want to have everything as cleaned up as possible. So this positive 9 and minus 4 can be combined together. 9 minus 4 is going to be positive 5. And then I'll just copy the 14x down. Copy the equals down, and I did nothing to the right-hand side of the equation, but don't be lazy and try not to have to rewrite it. Just copy it down to the next line so you can continue your work and to be able to do so in an organized fashion. So I find a lot of students get a little lazy with that and they don't want to have to write something down if it didn't change. But one key to doing math well is to be organized. And so we don't want part of our equation down here and part of it up here and trying to work from one part of the paper to the other. Just bring the information down to the next line so that it's all together so you can have a better idea of what you're doing. Now that we combine these like terms together, this problem is exactly like the previous 3 or 4 problems that we were just looking at. I have x on both sides of the equation. I don't want that. I just want x on one side of the equation. So I'm going to get rid of it from the right-hand side by canceling out the 13x. That's accomplished by subtracting a 13x. That's going to cancel it out. If I do that to the right-hand side, I do the same thing to the left-hand side. The 13x's are going to cancel out. 14x minus 13x, 14 minus 13 is positive 1. The variable part just gets canceled, gets copied down. The plus 5 we didn't do anything with, so we'll go ahead and copy that down. And the same thing with the negative 4 here. This minus 4 will now become a negative 4. All right. To get x isolated, we need to get rid of the plus 5. We can do that by subtracting 5 from both sides, and we'll get 1x, which I can write as just x. The 5's cancel out. The equal sign gets copied down, and then negative 4 minus 5 is negative 9. So make sure you consider both of those negative signs when you're coming up with that result. It's another common mistake. Students do all the steps right in solving the equation, but then they make a sign mistake with adding the numbers together, and they end up getting the answer wrong. So even though they're doing the problem, 90% correctly, you miss that last little step, you get the wrong answer, and MathXL just gives you no credit for the work that you've done. So you don't want to lose out on everything because of a minor mistake like that. So be alert, pay attention, think carefully with the negative signs. All right, so x is equal to negative 9. Let's take a look at number 20. We got 2 more to do on this video. Number 20, hopefully they don't get too out of hand before we get to the end here. So same kind of thing on this problem. We have 5x plus 4 plus 6x plus 9 equals 10x plus 5. So as I said on the previous example, I'll say the same thing here. So I'm sorry if you're watching this video straight through, you're probably getting tired of me repeating the same thing over and over, even though it's not a bad thing to do. But if you're kind of skipping to particular problems, you'll need to know this. Before I start moving terms from one side of the equation to the other, so before I subtract this 10x away from the right-hand side and put it over here on the left-hand side, it's a mess over here. The left-hand side, we have multiple terms, multiple x's. We don't want to be bringing another term into that mess. So before you start moving things from one side of the equation to the other, clean up any messes that are there first, then start subtracting numbers from one side to the other. So I will combine like terms. Now be careful about this, because a lot of students get carried away based on what they did previously on the homework, and they think, well, to bring this 6x over to this 5x, I have to subtract it over there. And the truth here is that you don't have to do that, because they're already both on the left-hand side of the equation. So if I were to say I'm going to subtract 6x here to cancel out that plus 6x and bring it over here, well, really, I've subtracted 6x from the left-hand side of the equation twice. So look at where the equal sign is. I'm doing this twice on the left-hand side. To balance that out, I would have to do it twice on the right-hand side. And I really don't want to be doing that. It's just going to make a bigger mess of the entire equation. So let me just erase this idea here. So you don't need to subtract the 6x to bring it over here to the 5x. They're already together. They're already on the same side of the equation. All we have to do is combine them together. And you don't need to worry about the plus 4 in between them. These terms can be moved around, so sometimes I don't usually write this out, but the way you can think of it is like this. I can rewrite this as 5x, and then I'll put the 6x next. The order of these terms really doesn't matter. So if it makes you feel better to have them side by side, rearrange the order of these terms. Then I'll put the plus 4, and then I'll put the plus 9. And even though I'm not doing anything to the right-hand side of the equation, just to keep organized, I'll go ahead and copy that down. And now you can see we just combine these together. You don't have to change the sign of anything here. Just combine them together the way they are. We have 5x plus 6x. 5 plus 6 would be 11. The variable part gets copied down. And the same thing with the numbers here. These are like terms. 4 plus 9 can be added together to give us 13. So you want to do that first before you start moving things from one side of the equation to the other. And they're trying to trick you here. They put the plus 4 here on purpose because they want to see if you'll make that mistake of subtracting the 6x over to the 5x. So just remember, if they're already both on the same side of the equation, you don't need to change the sign of any terms to bring one over to the other. They're already together on the same side of the equation. And anything in between can just be ignored. You can just combine the 5x and the 6x together. Don't worry about that plus 4. Just move it out of the way. Right. So 5x and 6x gives me 11x. 4 plus 9 gives me the 13. Right. And you can skip this middle step of rearranging the terms. Right. Once you've done that, it's exactly like the problems we've already done previously. We want to get x on one side of the equation, so I will get rid of the 10x from the right-hand side by subtracting 10x. To balance that out, I got to do the same thing to the left-hand side. On the right-hand side, the 10x's are going to cancel out. Here we're going to get 11x minus 10x, which will be 1x. I'll copy down the plus 13, copy down the equal sign, copy down the positive 5. And then to get x by itself, I need to get rid of the plus 13, and I can do that by subtracting 13 from both sides. And I'll go ahead and, since I'm out of space down here at the bottom, I'll write it over to the side. We have 1x, which I can just write as x, right? Because 1 times x is just x. The 13's cancel out. I have the equal sign. And then 5 minus 13, again, be careful with these negative signs. You don't want to get this far doing the problem correctly, only to stumble here with a negative sign and end up with the wrong answer. All right, so 5 minus 13 is negative 8. And so we get x is equal to negative 8. All right, last problem. Let's see what we have here. Number 21, last problem for this video anyways. So same thing, same kind of problem. We have 9x plus 5x plus 4 plus 8 equals 10x plus 4 plus 3x. So there's throwing a whole bunch of terms in there. But if you just follow the same strategy that we did on the previous example, number 20, you'll be just fine. You just need to clean up the left-hand side and the right-hand side first, and then solve the equation in the usual fashion. Right? So we'll combine like terms over here on the left-hand side. You do not need to subtract the 5x to bring it over here to the 9x. They're already both on the left-hand side of the equation. All you have to do is combine them together. 9 plus 5 is 14. And then you copy the variable part down. So this would be 14x. 4 plus 8 is going to be 12. So combine those two together. So now the left-hand side's all cleaned up. We simplified it as much as we can. We do the same thing to the right-hand side. We have a 10x and a 3x, and even though there's this plus 4 separating the two of them, they're both on the right-hand side of the equation, so we can just go ahead and combine them together. You do not need to subtract the 3x over to the 10x because they're already both on the right-hand side of the equation. Just combine them together as if the 4 is not even there. 10x plus 3x will be 13x. Right, 10 plus 3 is 13. And then the plus 4 just gets copied down because it's not doing anything. There's no like terms to combine it with. All right, so once you've simplified the left-hand side and the right-hand side first, it becomes an equation very similar to the ones that we were doing previously. We want to get x by itself on one side of the equation. I'll start by getting rid of x from the right-hand side. I can cancel out the 13x by subtracting 13x from the right-hand side. To balance that out, I got to do the same thing to the left-hand side. So the 13x's are going to cancel out on the right-hand side. And then on the left-hand side, we have 14x minus 13x, which will be 1x. Notice every time in section 10.1, that's what we end up getting, just 1x, because we haven't talked about how to deal with any other number there yet. We're going to do that in the next section. The plus 12 just gets copied down, and the plus 4 just gets copied down. Sorry, and because it's positive, we don't need to bring down the plus sign, which is what I almost did there. All right, now to get x by itself, we need to get rid of the plus 12. We can do that by subtracting 12 from both sides. We get 1x, which is just x, right? 1 times x is just x. The 12s cancel out. Copy down the equal sign. 4 minus 12 will be negative 8. And so our solution will be x equals negative 8. All right, we'll take a look at the last 7 problems in the next video. As soon as I can stop this video.